In example 3, we have f of x equals x to the 4th minus 4x cubed. And again, it asks us to find where this graph is increasing, decreasing, has relative maxes and mins. So showing our analysis and justifying our answers. So that justifying our answers is important. That's where we use the derivative to explain how we got our values. So you'll do the same process as in the last problem. You'll find your derivative, find your critical values, make your sign chart, and then write your analysis. So I think you might be able to try this one on your own first. So I would suggest actually pausing, try it on your own, and then check back. All right, so our first step, we find our derivative. F prime of x is 4x cubed minus 12x squared. We're going to set that equal to 0. This is a polynomial, so it will never be undefined. I can factor a 4x squared out of both terms, and I'd have x times x minus 3. And so my critical values are 0 and 3. Now I make my sign chart for f prime. 0 and 3. Pick some test points, -1, 1, 4. You can choose whatever you want in that interval. Just make sure it's actually on that interval. If I plug in -1 to 4x squared, that's positive, and into x minus 3, that's negative. So this interval is negative. If I plug in 1, I have positive and negative, so this interval is also negative. If I evaluate at 4, I have a positive and a positive, so that is positive. One shortcut on these sign charts, I can see here that at 0, the sign doesn't actually change. It's negative on either side. And the reason why is when I look at my derivative, that term was 4x squared. So when that exponent is even, the sign won't actually change. So I know it won't change at that 0, but it would change at 3 because that just has an exponent of 1. So I know the sign will change from negative to positive there. So let's write out our justification. For decreasing, we're going to look to see where our derivative was negative. So we've got negative here all the way through here. And so you can write that as a continuous interval. So f is decreasing on the interval from -infinity up to 3. Since f prime is less than 0, and we're looking to see where it's less than 0, not equal to 0, so -infinity to 0 union 0 to 3. Same idea for increasing, that's from 3 to infinity. So I accidentally wrote parentheses there. You could write this as parentheses if you want, or you can use a bracket. And this is what I was saying before. Either of those would work on the AP test and on our test. Our justification is since f prime is greater than 0 on the open interval 3 to infinity. The last thing we have to look for is relative maxes and mins. So you're looking for that sign change. You can see here at x equals 0, the sign did not change, so that's not a max or a min. So not all of your critical values will be maxes or mins. They're just possible maxes or mins. At 3, though, I see that my derivative changes from negative to positive. So this will be, again, a relative minimum. So f has a relative min at x equals 3, since f prime changes from negative to positive. In number 4, we're given the function f prime of x equals x cubed plus 21x squared plus 90x. We want to determine where f is increasing. So we don't even have f of x here. What we have is f prime of x. But don't let that deter you, because what that means is we've already done this first step. So it's already been done for us. We don't even have to know what the original f of x was. And so we can just go ahead and set this equal to 0 and factor. So we can factor out an x first. and we're setting this equal to 0. And then I'm looking for two numbers that multiply to 90 and add to 21. Those would be 15 and 6. So we have x times x plus 6 times x plus 15 equals 0. Set each term equal to 0, so we would have x equals 0, negative 6, negative 15. Those are our critical values. If we're determining where f is increasing, we need to make our sign chart. And so, actually, let me make that a little bit bigger. We've got a lot of numbers here to plug in. We've got negative 15, negative 6, and 0. And then you can check your test points again. You could plug those in. So like negative 16, maybe negative 10. You can choose whatever numbers you want. Again, negative 1, positive 1. So if I plug in a negative 16, this would be negative, negative, and negative, which overall is negative. If you want to use that trick I talked about in the last problem, all of these have a power of 1 on the factor, which means the sign will change every time. So this is going to go negative, positive, negative, positive. That's just a little shortcut for you. And so we don't have to do all of the work that we had to do in the last problem. We're just looking to see where f is increasing. And so that means, again, I'm going to check to see where my derivative is positive. So that's between negative 15 and negative 6, and after 0. And so let's write out our justification. F is increasing on negative 15 to negative 6, union 0 to infinity, since f prime is greater than 0 on negative 15 to negative 6, union 0 to infinity. So far we've been doing this function analysis just by looking at the equation of a function f of x. And we can do the same thing though when we look at the graph of f of x, or f prime of x actually. And so when you have these graph problems, it's super, super, super important to pay attention to what you have the graph of. So pay attention here that this is the graph of f prime, okay? So graph of f prime, and it should be labeled on your graph as well. And so when it asks us to determine where f is increasing, I'm not looking at this graph to see where f is increasing because this is the graph of f prime. I have to convert this statement into what the derivative means because this is the derivative. So if f is increasing, that means that f prime is greater than 0. So I'm going to look to see where this graph is greater than 0. So that means where is the graph above the x-axis. So I see here it's above, above, above until negative 5, and then it keeps on going above all the way until I get to 1. And then it's also above from 8 to 9. And so that tells me that my function is increasing. So these are open endpoints, so make sure you use open intervals there. From negative 9 up through, I can skip negative 5 all the way to 1, union 8 to 9. There. And if I wanted to write out a justification, which it doesn't ask me to do here, I would say f is increasing on this interval since f prime is greater than 0. Okay, for decreasing, I'm thinking about where my derivative is less than 0. So when I look at my graph, I'm going to look to see where I'm below the x-axis. So you cannot write that as a justification, though. You don't want to say because f prime is below the x-axis. We're just using that to match up where f prime is less than 0. So that's this other interval from 1 to 8. For C, it asks where f has a critical point. So that means where f prime is 0 or undefined. So my f prime is totally defined here, so I don't have to worry about that. So I'm just looking for my zeros. So my zeros would be at negative 5, 1, and 8. For a relative max, it could be at one of those 3 points that we had before, one of the critical values. So you're looking at your x-intercepts. But what you have to pay attention to for a relative max is I'm looking for f prime to change from positive to negative. So that means I'm going from above the x-axis to below the x-axis. So here I don't cross. That can't be a max. Here I change from positive above to below. That's negative. So that is a relative max of f at x equals 1. This other point 8, I'm changing from negative to positive, and so that's my relative minimum. Okay, so relative maxes of f will cross the x-axis from above to below on f prime. So this is x equals 1 for a relative max, and a relative min of f at x equals 8. So I know this can get tricky. We're talking about a graph of f that we don't actually have, but if I were to graph f at 1, I would have a max because f prime changes from positive to negative. So again, I'm not actually looking at the relative maxes and mins of this graph because this is the graph of f prime. So just try to keep that straight. And then x equals 8 was a relative min because f prime changed from negative to positive.